All right. Welcome to Unit 10, Electrodynamics. We're going to start with an easy one, the simple circuit intro. This is totally reliant on PRT4. Here it is. In fact, the equations we'll use, you notice there are 8 running down the left-hand side. We're primarily going to focus on equations 5, 6, 7, 8 down here. 5, 6, 7, 8. Notice 7 and 8 are multi-equations. Essentially, you can use these as P equals VI, P equals I squared R, P equals V squared over R. You also, for the work energy equation, W is PT, W is VIT, W is I squared RT, W is V squared T over R. So though these are equations 7 and 8, in a sense you could call this 7, 8, 9, and then 10, 11, 12, 13. So there are a few more on here than meets the eye at first. We still have equations 1, 2, 3, 4 that we've been using, and these are not out of the picture by any means. So one of the things you'll do, you'll write in the equations here, and then you'll write the physical quantity symbol. The symbols are here. For example, the first one was resistance. So you find the word resistance, you see the symbol is R, and of course you put an R there. The reason we're doing this is when we set up our givens, you're going to use the symbols. Resistance has a unit ohm. There's a symbol for the ohm. The others you have done. So potential difference, you know the symbol. Power, work, current, and time. You know all of these. You can look up the symbols if you need to, but you know them, you've used them. You also know the units for all of them. Okay, good. The questions primarily are very straightforward as long as you follow your givens. So question 1, for example, put our givens with units. A 2 kilo ohm resistor is connected to a 5-volt battery. Determine the current through the resistor. Well, if you use your symbols up top, ohm, you know, goes with resistance. It also says the word resistor, so that's going to be your R equals 2.0. This is kilo ohms. Kilo means times 10 to the third ohms. 5 volt. Volt is a unit for potential difference. So that is your V equals 5.00 volts. And then determine the current. Current, of course, I equals, and you know the unit here, one of the units, but the most common, the fundamental SI is the ampere. Now, you go back to your reference table, or actually the list you made up top, there is an equation that combines our givens, R, V, and I. So R equals V over I, there it is. You'll write your equation, R equals V over I. This one is solving for I, so you'll do a quick rearrange. I equals, this is a cross multiply, V over R, and you'll solve this. So these are all very similar. And you come down to these others, notice 1500 watts of power, so you can use the power equation figuring this out. Okay. On the back, similar problem, similar problem, similar problem. How long, you're solving for time. Also, this note over here, don't forget, the first 4 equations still hold, meaning these 4 up here. So if the givens fit those better than 5, 6, 7, 8, use them. Let the givens drive your choice. All right, the part I primarily want to talk to you about was actually question 9. So question 9, they asked for alternate units. You cannot predict how this would show up on an assessment, but the process is the same for all, so it should be very straightforward. So the unit is joule. Now joule, you know, is a unit for W. So I asked you to provide the alternate units for the joule. We have 5 from PRT4 and 1 from Chem. So let's check out how this works. The easiest way to do this is find any equation with a W in it for work or energy because the unit is joule. For example, we have this equation has a W and all of these have a W. How do you go about it? Well, first off, rearrange it so it's set equal to W. W equals cross multiply V times Q. So of course here, W, which we know is a joule, is also equivalent to potential difference is a volt, charge is a coulomb. A volt times coulomb, or coulomb times volt. So there's one of your answers, volt dot coulomb. Then there are other answers. Here's how the process works. Work is also, looking down here, power times time. So power, we know, comes in watts, time comes in seconds. So the watt second is an option. It's also equivalent to VIT. Well, V is volts, I is current, which is amperes, T is seconds. So this is also equivalent to a volt, ampere, second. Of course, we can come back over here using I squared RT. I is current, which would be ampere squared. R is resistance, which is the ohm that's written on the first page of your homework. And time is seconds. So another option is the ampere squared ohm second. And of course, the final option here, V squared T over R. V is potential difference, which comes in volts. So volts squared. Time is seconds. R is resistance, which comes in ohms. So the volt squared second over ohm. So notice that there are 1, 2, 3, 4, 5 different units that are equivalent to the joule. And that's how you actually go about doing these. Just manipulate the equations and get them so that they're equal to what you're looking for. So those would be the 5 from PRT4. And of course, the chem unit for work, which hopefully you remember, is the electron volt. So it's the same process with these. Just rearrange the equations, see what they're equivalent to. It's actually nice practice. It'll help you remember your units. Then, of course, on the graphs, your y-axis, your x-axis, set that up. That's old news. Okay. Enjoy.